So, last class I have discussed about the two checks that we have to do to design a retaining wall, and now this class I will discuss about the two more checks that we have to perform during a design of retaining wall. Okay. So, so these were the things that I was discussed. Then this is the factor of safety under no sliding condition. This is the factor of safety under no overturning condition. So, next one, the third one is the no tension condition. Okay. So, there should not be any tension developed in the base of the retaining wall. As I mentioned that you can see that there is eccentricity. Okay. So, that means the stress distribution below the base of the foundation of retaining wall is not uniform, because as there is eccentricity. So, forces or stresses may be more will be more in one side and will be less in the other side. So, that no tension condition you have to satisfy that your E cannot be greater than B by 6. Okay. So, otherwise if, as I have discussed this thing during the shallow foundation design also. So, this is the condition that Q mean and this is Q max. So, this is the condition for E equal to less than B by 6, then this is the condition for E equal to B by 6, and this is the condition for E equal to E greater than B by 6. So, this two is okay for the design, this we will not accept, because soil cannot take tension. So, there will be a separation between the soil and the wall base. So, that is not recommended. So, you have to check the no tension conditions as that E cannot be greater than B by 6, because we will design under these two conditions only. And the fourth one is the no bearing capacity failure or bearing failure. Okay. So, this P max or the Q max you can calculate by using these expressions. So, P max or Q max or Q mean, we can calculate that R V dash divided by B 1 plus minus 6 E divided by B. Okay. So, here your Q max is equal to R V dash divided by B 1 plus 6 E by B, and Q mean is R V dash divided by B 1 minus 6 E by B. So, in this this minimum, if E is equal to B by 6, then it is 0. If E is equal to greater than B by 6, then it will be negative. So, that is not recommended, that is why. So, the factor of safety for this case will be the Q net ultimate or net ultimate and divided by the this Q max that is acting, and that should be greater than equal to 2.523. Okay. So, this is the stress which is coming from the wall, and this is the Q max that we will calculate. Okay. And so, these are the 4 checks that you have to do during a design of a retaining wall. So, and we will solve 2 problems considering this regarding this design of retaining wall. One is for the cantilever retaining wall, another is for the gravity retaining wall, and those and there we will use these theories and we will check these 4 conditions, and we will try to satisfy those 4 conditions during our design. Okay, the next one, the another important thing, that if I use Rankine theory during a design of retaining wall, and if I use Coulomb's theory during a design of retaining wall, what are the differences? Okay, what are the things we will consider, what are the things we will not consider. Okay, so, that is why it is very important to explain that for the first one, that we are talking about that the Rankine's theory, and this is Coulomb's theory. Okay. So, I am considering a similar type of wall for both the cases, that sorry. So, we will consider, we will take a wall, and then so this is the backfill surface which is horizontal, and this is the wall, and this is the foundation level. Similarly, I am using say Coulomb's theory for this type of wall. Okay, this is also foundation, this is also the backfill. And when we are talking about the Rankine and we are talking about the Coulomb, the first we will discuss about the Rankine's theory. Now, when you first check that you can apply Rankine theory or not. So, in the figure also I have shown that there is a line that, and this case this angle is, oh sorry, this will go from here. So, this is a line that will go up to here, and this is the point alpha, and this is the eta. Okay. So, you check that your alpha value is 45 degree plus phi by 2. Okay. So, that means you can apply Rankine's theory if this line passes within the backfill, or this is the limit. So, this line, this dotted line cannot pass through the stem of the wall, it will not pass through the wall. Okay. If it is passes through the wall, then you cannot use the Rankine's theory, you have to go for the Coulomb's theory. Okay. That is the first condition for Rankine's theory design. And if it is say inclined backfill, if it is the inclined backfill, then if it is inclined backfill, with the inclination of I, then this value of alpha will be 45 degree plus phi by 2 minus I by 2 plus sin inverse sin I divided by sin phi or phi dash. Okay. So, similarly, this your here eta will be 90 minus 45 degree minus phi by 2. This will be 45 degree minus phi by 2. And for the inclined backfill, this will be 45 degree plus I by 2 minus phi by 2 minus sine inverse sine I sine phi. So, we have to satisfy this condition before we apply this Rankine theory, that this line, this dotted line should not pass through this wall. It will always pass through the backfill, and this is the limit. Okay, that is the first condition. Suppose if it is satisfied, you go for the Rankine. If it is not satisfied, you go for the Coulomb. Now, if it is satisfied, you are applying the Rankine's theory. Then this, remember that this Rankine's theory, this force will act at the edge of this base. Okay. So, you have to apply this force, and which is parallel to the wall, parallel to the backfill with a height of h by 3. But in case of Coulombs, you have to apply here, okay, and with an angle delta. This is the normal. So, this is 90 degree. So, this is the first difference, that you have to apply this force here, and here you have, for the Coulombs you have to apply on the wall surface, and it is on the soil surface. If it is inclined, say suppose if your backfill is inclined, then this force will also be inclined. Okay. But even if here it is inclined, still it will act with an angle of delta. So, both the cases with an angle of delta with the normal to the wall. So, both the cases it will act in the similar condition, but here the direction will change. Okay. Now, the next one is that when you use the Coulomb's theory, then you will only consider weight of the wall. Do not consider the weight of the soil during the stability calculation. But when you use the Rankine's theory, you use the weight of the concrete as well as the weight of the soil. Okay. So, here only WC is considered. Okay. Here the WC and WS both are considered. So, remember that these things are very important. Okay. So, when you use the Coulomb's theory, we will use only the WC during stability calculation, but when we are talking about we are using about the Rankine's theory, then you have to consider both UC and WC and WS. Okay. So, these are the basic difference between the Coulomb's theory and the Rankine's theory. And so, now I will solve one problem which is related to the gravity retaining wall, and then we will solve the problem for cantilever retaining wall also. So, first one we are taking an example problem. Okay. So, this is for the gravity retaining wall. Okay. So, I have taken because in the gravity retaining wall I have given you the tentative dimensions. So, I have followed that thing, and I have chosen one particular dimension for the first trial, where the weight of the wall h value height of the wall is 4 meter. Okay. So, this is the wall dimension that I have chosen. This is the backfill surface, which is horizontal, and this is the foundation, and foundation depth minimum was 0.6. So, I have taken 1 meter as a foundation depth. So, d value is equal to 1 meter, and this height is 4 meter. Okay. So, this height is 4 meter. So, h value is 4 meter. So, this is 2/3 of h. So, I have taken this value is around, this is 3 meter. First trial I am taking, this is 3 meter and this is minimum 0.3. So, I have taken 0.3 meter and this value I have taken 0.5 meter. So, that means this one is also 0.5 meter. Okay. And this value I have taken 0.65 meter, that is h by 6 you can choose. So, I have taken 0.65 meter. This one for the first trial also I have taken 0.65 meter. Okay. So, this is 3 meter, this is 0.65, 0.65, this is 3. So, finally, this portion, this is 0.7 meter and this is also 0.7 meter. Okay. So, this is 0.7 meter, this is 4 meter. So, the alpha value is I can calculate. So, the properties are given, I is equal to 0 with no inclination. So, beta value is, we can calculate that the alpha value is, this is the tan inverse, alpha value tan inverse, this is 4 meter up to here, this is another 0.5. So, 4.4 meter plus 0.5 divided by, this is 0.7. Okay. So, this is the tan inverse. So, this value is coming out to be 81 degree. So, beta value is 90 minus 81 degree. So, this will be 9 degree. Okay. So, beta is this one. Fine. So, beta is 9 degree, alpha is 81 degree. So, properties are given, phi of the backfill is 40 degree. Okay. And delta is given, generally is taken 2/3 of phi. So, that is 26.7. Delta value is given to, is nothing is mentioned, you take 2/3 of phi, but here 2/3 of phi is the delta is given. Unit weight of the soil is 18 kilonewton per meter cube. So, these all properties are backfill soil property. Okay. So, actually these properties I am talking about, these are the properties is 40 degree phi, delta is 26.7 degree and unit weight is 18 kilonewton per meter cube. But the base soil can be different properties also. Here the base soil properties are given, C is equal to 25 kilonewton per meter square, alpha is equal to, alpha is the adhesion factor here. This is the adhesion factor is 0.9. So, your C equal, Ca is equal to alpha into C. So, this is 0.9 into 25. Okay. And phi value is given 20 degree and delta is given 0.75 of phi, that is 15 degree, and unit weight of soil is again 18 kilonewton per meter cube. Okay. So, this is the soil properties and we have to design the retaining wall, and this and we are using the Coulomb's theory here. Okay. So, we are using Coulomb's theory. So, that is why it will act here, this is the perpendicular line with an angle delta, this will be the P A. Okay. And this point of application is from here, it is. So, this total height is 4 plus 1 divided by 3. Okay. So, it will act at a height of 1.67. So, this is 1.67 meter. Okay. So, this is the total geometry and the properties of the soil. Now, we have to design it. So, I have taken this dimension for the first trial. So, what I am doing? I have to calculate K A, and K A expression is given sin square alpha plus phi divided by sin square alpha sin alpha minus delta 1 plus root over sin phi plus delta sin phi minus I sin alpha minus delta and sin alpha plus I, that is whole square. So, if you put these values, you put alpha is equal to 81 degree, phi is equal to 40 degree, because when you calculate K, you use backfill phi. Okay. So, this is the 40 degree and sin alpha delta is 26.7. So, if you put this value, so ultimately this is K A is coming out to be 2.256. Your delta is given 26.7, I is 0, alpha is 81. So, you put all these values. So, it is 0.256. So, my P A value is half gamma K A into h square. So, this is half, but here it is h dash you are saying because your h is 4 meter. Now, I am taking from the base of the wall to the top. So, your h dash is h plus d, okay, and this will be 4 plus 1 5 meter. Okay. So, I can write this is equal to half into unit weight is here unit weight is 18, K A is 0.256 and this is 5 square. So, this value is 57.6 kilonewton per meter. Now, it has two components. Okay. It is acting in this direction. So, it has two components, one is horizontal and one is vertical. So, this is making an angle with this horizontal is this is also beta. If this is beta, this angle is beta and this angle is beta, then this angle is also beta. Okay. This is 90 degree because this value is 90 degree and this is also beta. So, my P, so I can write P A H horizontal part is P A cos delta plus beta. Okay. So, I can write this is 57.6 cos delta is 26.7 and beta is 9 degree. Okay. So, this is 46.8 kilonewton per meter, 46.8. Similarly, the vertical part P A V, because now what we are doing, this P A as this is the P A and it is making an angle delta plus beta with the horizontal. So, it has two components. We can write this is one component and this is another component. So, this is called P A V, this is called P A H. Okay. Now, similarly, P A V is P A into sin delta plus beta. So, this is 57.6 into sine 26.7 plus 9. So, this is 33.61 kilonewton per meter. Okay. So, now I am using the Coulomb's theory. So, I will not consider the weight of the soil during the force calculation. So, I am taking the various components. So, this is the segment 1, this is segment 2, 3 and 4. So, this is a triangle, this is a rectangle, this is a triangle and this one is the rectangle. So, that I am taking for the force calculation. So, now I will calculate the forces. Okay. So, now I will calculate the forces, and so I will make a table with the first I will make a vertical forces, the unit is kilonewton per meter, then the horizontal forces, unit is again kilonewton per meter, then I will take lever arm, lever arm is meter, then I will take MR, that is the resisting moment, kilonewton meter per meter, and MO, overturning moment, kilonewton meter per meter. So, this is the table. So, serial number 1 for the W1, W1 is the for the first part, and first part is this one whose height will be 4 meter, 4 meter is up to here, this is up to here, it is 4 meter, then plus 0.5 meter. Okay. So, this is also 0.5. So, this will be 4.5 and this is 0.3, and the unit weight of concrete is given, concrete is given 24 kilonewton per meter cube. So, I can write here for the first one will be 0.3 into 4.5 into 24, that will be 32.4, where 24 the unit weight of concrete. So, I can write the unit weight of concrete is 24. Then the it is perfectly vertical. So, horizontal is no forces. Second one, the W2 I will calculate for this one whose length is 3 meter and this height is 0.5. Okay. That is also concrete. So, this will be 3 into 0.5 into 24. So, this will be 36. Then I will go for the W3. Okay. W3 is this triangular portion whose height is 4.5 and this width is 0.7. Okay. So, I can write this is half into 4.5 into 0.7 into 24, that is equal to 37.8. Number 4 is the W4, which is the same as W1, 37.8, because W4 is same as W3. So, it is 37.8. Okay. Then number 5 is the horizontal force, that on number 5 I can take this vertical component. Okay. So, this vertical component PAV. So, PAV is 33.61. So, I am taking PAV 36 point. So, this is PAV, that is 33.61, and number 6 I am taking P, this is the horizontal one. So, this will be the PAH, that is equal to, because here only horizontal force is this one PAH, that is 46.8, all other forces are vertical forces. Okay. So, because this is PAB vertical, PAH is the horizontal force. So, I am taking PAH is 46.8, it is 46.8. So, now the total summation of all horizontal forces, that is giving again 46.8 kilonewton per meter, and summation of all vertical forces is, if you add these 1, 2, 3, 4, 5 forces. So, this will coming out to be 177.61. This is 0.61 kilonewton per meter. So, summation of all vertical forces. So, vertical, this is V and this is H. Now, the lever arm. Okay. So, the lever arm part. So, first I am talking about the first vertical force and the lever arm. So, let us see that I am taking the moment from this toe. This is the toe. The first one, lever arm will be, so this will act at the center. So, 3/2 is the lever arm, because it is acting, because this is at the center point. So, it will act at the center of the wall. So, first lever arm for the first one will be 3 divided by 2, 1.5. Okay. Then the second one is also will act at the center of the wall, because that is the middle portion. So, this is also 3/2, 1.5. Now, for the third one, so it will act from this side 2/3 of 0.7 and this is 0.65. So, 0.65 plus 2/3 of 0.7, okay, because this is the triangle. So, this side is 1/3 of 0.7. So, I am calculating from this side. So, this will be 0.65 plus 2/3 of 0.7. So, this will be 0.65 plus 2/3 of 0.7, that is equal to 1.12 meter. Okay. Now, for the fourth one is 0.65 plus 0.7 plus 0.3 plus 1/3 of 0.7. Okay. So, it will be 0.65 plus 0.7 plus 0.3 plus 1/3 of 0.7, that is equal to 1.88. Okay. Then for the, this is the fourth and the fifth one, PAV, because now PAV is acting here. So, now let us discuss that PAV part. Now, PAV is acting. So, this is the wall and PAV vertical one is acting here. So, here this is the PAV and here it is PAH and this is PAV, and this one from here to here it is 5/3. So, 1.67 meter. Okay. So, I can write. So, this one is 0.5 meter. So, from here to here it is 1.17 meter, 1.65 minus 0.5, 1.17 meter. So, I know this angle. So, this is 81 degree and this height is 1.17. So, I can determine that this height where it is, or this distance where it is acting. So, this distance is 0.185, because you know this height, you know this angle. So, you can calculate this one, you know this height. So, this one is you can calculate, because this height I know, this angle I know. So, I can calculate this is 0.185. So, my PAV is acting as, where it is acting. So, I can, this is 0.65 plus 0.7 plus 0.3 then 0.7 minus 0.185, because it is acting from this side 0.85, 0.185. Okay. So, it will be, this is the fifth one, 0.65 plus 0.7 plus 0.3, then plus 0.7 minus 0.185. Okay. So, that is equal to 2.165. And where pH is acting? pH is acting this height, this is 1.67. So, pH is 1.67. So, these are the all lever arm. Now, you have to multiply this lever arm with the vertical force. So, this is the, if column number 1, this is column number 2. So, this is column number 3. So, column MR is column number 4 is equal to 1 into 3, and column number 5, this is equal to 2 into 3. So, I am just showing one calculation. So, for the first one, I am showing that this will be 32.4 into 1.5. So, this is equal to 48.6, and resisting moment will be nothing. Similarly, for the W2 also, I can write this is 54. Okay. Then W3 it will be 42.3, then W4 it will be 71.1, then PAV, due to PAV it will be 72.8, and then for the last one, this is the overturning, the horizontal one is giving overturning moment, and that is equal to 46.8 into 1.67. So, that is equal to 78.2. Okay. So, now I am taking the summation of all overturning moment. So, that is 78.2 kilonewton per meter, and the summation of all resisting moment. So, that is equal to the summation of you add this column 4. So, you will get all the resisting moment is 288.8 kilonewton per meter. Okay. So, these are the all calculation that I have done for this problem. So, now first I have done all the calculations. So, in the next class I will use these values to check the stability of this retaining wall against sliding, overturning, and then I also check the no tension condition and the bearing capacity. Thank you.